Hello everyone, welcome back to another exciting chemistry video lessons. Now in this particular video, we're going to be taking a question on Lewis structure and other aspects surrounding it. Now this video is actually very important for students that are preparing for what? For WAEC, JAMB, AP, A-level exams. Now the question says, briefly explain the shape of phosphorus pentachloride, iodine trichloride, and boron trifluoride on the basis of valence shell electron pair repulsion theory. We pick the first one, which is phosphorus pentachloride. Now what do we do here? The step one in drawing for the Lewis structure is that you calculate for the magic number. Magic number A is equal to, now the valence electron for phosphorus. Of course, you are aware that phosphorus is what now? Is 15. And the electronic configuration using the orbit method is 2,8,5. So the valence electron here is 5, which also makes up the group. In fact, we pick the group. So phosphorus is in group 5, which is 5, plus the group of chlorine is 7. So 7 multiplied by this 5 here. So altogether becomes 5 plus 7 times 5 is 35. Altogether is 40 what? Electrons. Right? Now, hence we are able to calculate for the magic number. The next step is to know between this phosphorus and chlorine which should be my parent element. And a parent element is the element that is fewer in number or that has the highest what now oxidation state. But in this case here now, phosphorus here is 1, chlorine here is 5 atoms. So because phosphorus is fewer or is just 1, it becomes the central element, which will be at the middle here. Now this other element will be spread across it, as you can see here. So we carry chlorine, we put chlorine here, we put chlorine here, chlorine here, chlorine here, chlorine here, until see 5 chlorine. So we continue now. Now let's continue. Take note, we have been able to give it one bond each, right? The next one is to complete its octet, because every element want to attain stability by attaining the duplet and octet configuration of state, even though there are few exceptions. Is that clear now? But the sole idea is that every element want to attain stability, and by attaining stability, we simply mean that they want to attain their duplet and what now? Octet form. So what do we do here? We make it to become, here already have 2 electrons here. So we put here like this. We put here like this. We put here like this. All in the aim of octet. So if you observe here now, here is simply what now? 8, which is 2, 4, 6, 8, 2, 4, 6, 8, 2, 4. So altogether here is, so it simply means that 8 here times 5 of the element, which is 5 atoms here, 1, 2, 3, 4, 5, is what now? 40 what? Electron. Nothing is remaining, right? Nothing is remaining. And as such here now, what do we need to know about it? So we already know that the central element here for this molecule is 5. Because we're trying to describe it now. The central element of phosphorus here is 5. That's 1. And that, does it have any lone pair here? Is there any lone pair here that is attached to this phosphorus here? No. So it has 0 what now? 0 lone pair. But how many bond pair? 5. 1, 2, 3, 4, 5. 5 bond pair. Am I correct now? Now that you know all these things, we can simply know or calculate for the hybridization. And to get for hybridization, we need to know that there's something we call region of high electron density, which is simply the total number of lone pair and bond pair ascribed to a particular central element in a molecule. Now, from here now, the central element here is phosphorus, right? Does it have any lone pair? No lone pair. Does it have any bond pair? Yes. What are the bond pair here? Single bond here, which is 1, 2, 3, 4, 5. And here it is what now? 5. We know that the region of high electron density is equal to the what now? Hybrid orbitals. Hybrid what? Orbitals. And when you have an hybrid orbitals of 5, it is simply an sp3d. And when you are sp3, which is 1 s orbital, 3 p orbital, which is 4, plus 1 w, which is what now? 5. So if you are having your hybrid orbital to be 5, then your hybridization should be sp3d. And if your hybridization is sp3d and you have no lone pair, the geometry, the molecular geometry is simply what now? Trigonal bipyramidal. Trigonal bipyramidal. When you are sp3d, you are trigonal bipyramidal. When you are sp3, right, without lone pair, you are tetrahedral. When you are sp, x orbital and a p orbital, when you are sp, your hybrid orbital is 2, your shape is linear, right? And please take note, for molecules that are sp3d or that are trigonal bipyramidal, their bond angles are 90 degree and what now? 120 what degree. Is that clear? And all this information here is what has given us an edge over the description of this molecule here, phosphorus pentachloride. You know that, you know what is in the central element. You should know whether it has a lone pair. You should know the bond pair. You should know the shape. You should know the bond angles. You should know the hybridization. All these are what describe the what now? The valence share electron pair repulsion. So that is for this first one. So we are moving straight away to the second one to also give it a little touch, but make sure you understand what I have just done here. But I will explain more in the second one. So let me erase the board. Let me erase the board. Now, in the second one here, which is what now? Which is this iodine trichloride. Of course, the magic number first. The valence, in fact, the magic number is simply the sum total of all the valence electron in a molecule. Just follow my step. Now, the valence electron for iodine is from the group. Here is group what now? 7 plus. Chlorine is also group 7. So 7 multiplied by this 3, right? It's now 7 plus 21, right? Which will give me what now? 28 what? Electrons. So, of course, what should be the parent element here? You can guess, or you can tell me. It is simply what? Iodine, because iodine has fewer atoms here in this particular what? Molecule. Iodine is 1, chlorine is 3. So, I put iodine as the central element, which is also the parent element. I therefore spread chlorine all across it. All across it. Is that clear? Now, when I spread it all across it, I will first of all give it single bond first. When I give it single bond, I will therefore now complete the octet. Here will become 8, which is 2, 4, 6. Of course, the bond pair. The same thing goes here. The same thing goes there, right? Now, what next are we to do here? I now ask myself, right? I ask myself, 8 here, right? Here is 8, here is 8, here is 8, which is 8 times, always do it like this. 8 times 3 is what now? 24. That 24, is it up to the magic number? No. Because at the end of the day, whatever you are doing here to be equal to the magic number. So hence it is not up to the magic number. And that you have 2 lone pair, which is 4 electrons remaining to make it to be, because here is 24. You need 2 lone pair, which is 2 electrons, which is 4 electrons. Now, what do? You will now have to put it on the central element, right? Because 4 is remaining, which is 1, 2, 3, 4, which is 2 lone pair. Am I correct now? So that is how it is. Then what do we now do now? You observe here that this iodine atom here now is now in its octet form, 2, 4, 6, 8. Though we have exception, it can be less, it can be more, but just know that what you are doing is correct. Now, the next step for us to do is to calculate for the RHED. But before then, what are some things we need to know here? Iodine here, which is the central element, which is your focus here. Iodine here has 3 bond pair, while it has 2 lone pair. Look at the 2 lone pair here. 2 lone pair, right? But 3 what now? Bond pair, meaning 2 lone pair, 3 bond what pair. Is that clear? 2 lone pair, 3 bond what now? Pair. Now, what is your RHED here? Your RHED here, which is equal to your hybrid orbital, is simply the sum total of these two here. So you have 2 plus 3 here, which is the lone pair, and the bond pair here, which is 5. And if it is 5, it is same as sp3 what now? D. Of course, if it is sp3d, right, there is always problem here. Is that clear now? If it's sp3d, be very, very careful. Be very, very careful. Now, take note that because this molecule has a lone pair, take note, because it has a lone pair, the shape will not be the normal shape you know, right? It will therefore become what now? Normally, if you are having sp3, if you are having sp3d, you ought to be what now? You ought to be trigonal bipyramidal without lone pair. But hence you having a lone pair, right? It will affect the shape and the structure of the molecule, because lone pair are stronger than bond pair. Is that clear now? And as such, what will therefore be the molecular geometry? It becomes what now? T what now? T shaped. T what? T shaped. And this is how it is done. Now, if this video has helped you, do well to like, share, and subscribe. And meanwhile, do for me this one and tell me your answer on the comment section below. And hence, subscribe. Thank you and God bless you.